Now this is our sixth. Now this is our sixth project, okay, and this is about word game or hangman game. This is game about in some file or a list, the computer chooses some random words, okay. We have to find that word giving letter by letter, and in that letter I'll give lives also, how many lives or choices it is there in that lives. You have to find that word. If you not found, the lives are finished and you must start from the beginning. Okay, we'll start a game. Now go to Google, type word list with over 5000 words. It comes like that. Then see, the Johnson file is there. Then go to this, then copy all of this, Control C, then go to this, then open a file, then open a file, then put words. In this word I'm printing words equals to Control V, all the words will print. Now delete this, that bracket, and delete this data. Still here you delete it, okay. Why I'm telling is that the database contains some error, so delete that, okay. After that it will not worry about the programming debugging, okay. Now I'm going to the program. Now in this function what I'm telling is that first I'm importing random function from words. This words we are given now, that word from this words I'm telling, from this words I'm telling import that words, then I'm importing string. Then in this I'm defining get valid word from words, okay. Then I'm printing word equals to random choice words. It chooses a random word. What this function is that it's telling if the word contains underscore or space, it will not choose that. It searches for another word that not contains underscore and space, and it searches for the correct word and return word. What and returning the word, it's does uppercase, okay. It's convert the word into uppercase letter, okay. Then here I'm defining the main hangman function, okay, hangman function. In this I'm putting word equals to the specific word equals to get valid words, okay. In this word letters, what is that? It contains all the letters in that word, okay. Set word, then alphabet, that specific letter I'm telling it to convert that letter into uppercase, okay. Then use letters. Use letter is that letter is already used. then I'm giving lives or choices. Now I'm importing the word, user word. Now in this while length of word letters is greater than 0 and lives greater than 0, then printing you will have lives and lives left and you have used these letters. What is this does means? See, it prints how many lives. You have only 7 lives and you have used this word. It will print like that. Okay. Now the word list. What this word list contains is that if that letter is already in used words, means print that letter, else it will give underscore. Okay. Then in this user letter I'm telling import guess a letter and telling that letter equals telling that letter change into uppercase. If user letter is alphabet minus use letter, if there is already use letters means I'm telling alpha letter minus used letters, sorry. Then used letters dot adding use letter. If user letter in word letters means word letters, remove user letter. What is this function is telling is that if the letter we already used means it will print that letter. Okay. Else lives equals to, then lives decreases by 1 after reprinting word by 1. Print your letter, user letter is not in the word. If the user letter is not in the word means it will print no, the letter is not in the word. Okay. Else if the letter is already used means it will print you have already used the letter, guess another letter. If all this function fails means else print that is not validated. What is this does means if anything if that word in the word the letter is not there means I'm printing another letter, that word is not having. If I print wrong word means it will tell this is not valid word. Then after the lives are finished it will tell you dead, sorry. If we found the word means it will print you guess the word correctly. Now I'm printing the word. Then last I'm telling main function, all this function I'm playing this hangama function. Or okay, yes, yes, okay, K P no J A V B O I think train T. Yeah, I guessed the word correctly. Now this is our fifth. Now this is our sixth project. This project is word game or hangam game. Now what is our seventh Python project is we are comparing native search, that is simple search, and binary search. Comparing and checking which searches in less time. Okay. Then in this project I am importing random and time. Now this is the function or program for native search. First I am defining native search and I am giving L and target. Okay. For I in range length of L, if I equal to target, return I, else return -1. What is native search does is it searches all the numbers from one by one and tells asks is one is our target, then no means it is searching on from the last till 12. Now 12 is our target. If it is searches 12 means it will return I, else it will return -1. If the number is not there in a target, it will return -1. Okay. Then the next algorithm or a program is binary search. What is binary search does is it runs on divide and conquer algorithm. Divide and conquer the algorithm means it searches for a midpoint. Okay, it splits into two, that is low and high. If the midpoint, the search or target has greater number, it will go to high, or the target has lesser value means it will go to low, and the steps going on repeating until it searches a value or a number. Okay. Then this binary search I'm listing L, target, and low I'm telling none, and high is equals to none. If low is none, then return no. If high is none, then high equals to length of L -1. Okay. If I less than low, then return -1. Then it search, I told no, searches for midpoint. How it's fine now. The midpoint means low plus high and divided by 2 and searches for a midpoint. Midpoint is captured me equal to target. It checks and return midpoint. Okay. Else if target less than midpoint, then return binary search L target low minus midpoint. Else return binary search L target midpoint plus 1 equals to high. It's keep on iterating until it searches a number. Then now Here I'm building the main function. In this I'm giving length and sorted list equals to set. While length of sorted list is less than length, then sorted list searches for random number in a list. Okay, then it returns sorted list, not sorted list. Then I'm giving time here for naive search and a binary search. Okay, I'm giving start time and end time and printing the start time minus n divided by length and giving the seconds. Okay, same as binary search. Now we will run the program. Now see, linear search takes microseconds and binary search takes now I'm running. Okay, now linear search takes milliseconds and binary search takes microseconds. Now binary searches in microseconds, it takes less time. Okay,